Okay, so good morning, everyone. Thank you for joining this panel discussion. It's already the final day of the UNISEC-Global meeting. Time really flies, faster than a satellite, we might say. So this evening, we'll be enjoying ourselves on the Yakata Bune, but first, we have to enjoy the final day of UNISEC-Global. So it's my great honor to kick off today's first event, which is a panel discussion titled UNISEC Constellation Mission. My name is Maximilien Berthet. I'm an assistant professor at the University of Tokyo in Japan. And one of my connections with UNISEC is that I used to be Rei Kawashima's English teacher in a program that she developed recently. So this is how I got involved. So before diving into the main part of the discussion, I'd like to provide some context, starting with the vision of UNISEC-Global. So UNISEC-Global aspires by the end of 2030 to create a world where university students can participate in practical space projects in all countries. And in fact, UNISEC has already come quite a long way towards achieving this vision through various frameworks, such as hands-on training, the HeptaSat training program and CLTP, as well as some platforms for knowledge exchange, including this meeting today, as well as the Mission Idea Contest, and by participating as an observer in the UN COP-UOS, and also by providing the seeds for space ecosystem development in various countries through the local chapters and points of contact. And this year, we are not only looking to the past, but also looking to the future, since it's the 10th anniversary of UNISEC-Global. So what does UNISEC-Global have in store for the next 10 years? So in fact, the answer to that question will be determined by all of us. All of us in the audience, by our panelists, and also by those of you listening online. So this is because UNISEC belongs to all of us. And one ingredient in this future, which we will be creating, is the UNISEC Constellation Mission. And in this panel discussion, what we hope to do is to start to explore the motivations, potential benefits, and challenges of such a constellation. So, but first, why a constellation, why now, and why in UNISEC-Global? So in fact, the history of UNISEC is closely tied with the idea of a constellation. Already in 2011, the first Mission Idea Contest was based around the idea of a constellation, and this year as well, the MIC was focused on using constellations or formations either in low Earth orbit or in the moon. And here you can see two of the awarded presentations in this year. And beyond UNISEC, around the world, constellations have started to develop, including SpaceX's Starlink and the Dove constellation by Planet. And these are being used for various applications like remote sensing, communications, store and forward, and also education. And we'll be talking later about the QB50 project in which some of today's panelists participated. So clearly there's a growing interest in constellations, and we'd like to explore how these can be developed within UNISEC. And today there are two objectives to achieve this purpose. The first is to gather some leading practitioners with expertise in space science, engineering, and education to talk about this topic. So we've already achieved this objective. We've gathered some expert panelists who will be sharing some experiences with us today. And the second objective, which is a little bit more challenging, is to start to chart a course towards the UNISEC-Global Constellation Mission. And we'll be doing this in 4 different movements. So first of all, I'd like to, in a few minutes, introduce the panelists. Then we'll talk about the main opportunities of the constellation, and then we'll move towards the challenges. And finally, we will provide some perspectives for the future. So this will be an interactive session. So I'd like to, at several points during the discussion, ask for your input through surveys and also by raising your hand. So please participate actively. So that's enough from me. And now I'd like to hand over to the panelists. So let me briefly introduce the constellation of distinguished panelists who will be speaking with us today. So we have Rostem Aslan, who is from the Istanbul Technical University in Turkey. So Professor Aslan is also known as the father of CubeSats in Turkey. His career at Istanbul Technical University spans over 40 years. And since 1999, he serves as a full professor within the institution. His distinguished achievements have included serving as the head of the Department of Astronautical Engineering for around 10 years, and also as the deputy director of the Rotorcraft Center of Excellence. He has 23 years of experience with end-to-end execution of space systems for numerous government and commercial programs. He started developing CubeSats in 2005, and so far he has managed and operated the launch of 7 CubeSats, including the first Turkish CubeSat. Next, I'd like to introduce Professor Herman Stein from Stellenbosch University in South Africa. Professor Stein is one of the pioneers of the space industry in South Africa. He earned his PhD in electronic engineering at the University of Stellenbosch with a focus on multimode attitude determination and control of small satellites. He then completed a master's in satellite engineering at the University of Surrey and returned to South Africa, serving as subsystem lead for the attitude determination and control of South Africa's first domestic satellite, SANSAT. So since 2001, Professor Stein is head of the Satellite Research Group in the Department of Electronic Engineering at the University of Stellenbosch. In this role, he's led the development of multiple satellites, including the only contribution of Africa to the QB50 constellation, which he will be talking about later. And he also helped establish the startup company CubeSpace, which has served over 100 overseas clients. So next, I'd like to introduce Professor Mungu Cho from Kyushu Institute of Technology in Japan. So Professor Cho is an acclaimed space educator with a focus on developing space technologies in emerging space nations. He earned his master's and bachelor's at the University of Tokyo before moving to Massachusetts Institute of Technology to earn his PhD in 1992. After serving as a research associate at Kobe University and as a teaching associate at the ISU in France, since 1996, he has been with the Kyushu Institute of Technology. He became full professor in 2004 and serves as the director of QTech's Laboratory of Lean Satellite Enterprises and in-orbit experiments. Since 2010, he has been actively involved in international space capacity building via nanosatellites and CubeSats, and his efforts have been recognized by awards such as the 2017 Airbus GEDC Diversity Award and the Frank J. Malina Astronautics Medal. And last but not least, I'd like to introduce Professor Masashi Kamogawa from University of Shizuoka. So Professor Kamogawa is a physicist and researcher of earthquakes, tsunamis, lightning, volcanoes, snow, and ice at the Natural Disaster Research Station, Global Center for Asian and Regional Research in University of Shizuoka. He obtained his bachelor's, master's, and PhD from Waseda University, and then he moved to Tokyo Gakuge University, where he served as assistant professor and then associate professor. And in his current role at the University of Shizuoka, Professor Kamogawa explores atmospheric electricity, earth electromagnetism, natural disaster science, and earthquake precursors. He also serves as executive director and secretary general of the Mount Fuji Research Station and as a board member of UNISEC. So I'd like to now briefly ask each panelist to introduce what they are now working on and how it fits into the concept of a UNISEC constellation mission. So Professor Aslan, if you'd like to share some thoughts.
Thank you, Max. Good morning. Well, currently I'm both teaching and still continuing to develop CubeSats. Well, of course, there are plenty of developments in the world of small satellites, both in the civilian and military sector. So I try to contribute to both. And also there are very recent and very fast developments in Turkey. So I'm also part of those. For example, there was a company established 2 years ago with already 5 operational satellites in orbit. And I think the increasing space awareness day by day, that's critical. I think that within the end of this century, we will be living in a three-dimensional, say, world or medium. And considering the planned projects following ISS, we will have many other, let's say, space stations, maybe space facilities, I would say, rather than stations. In my recent talks, I am using the cartoon Jetsons. Okay, well, of course, the difficulty is achieving travel within the gravitational environment. That's the only thing we need to overcome. But in that respect, there is the educational element. I'm an educator. I teach first freshmen and senior students. Freshman students, they start with building CANSATs, and senior students, they manage complicated deep space projects. And I value deep space projects from the perspective of being systems of systems of systems. Just working on a single satellite, well, I think you don't see the full spectrum. Within the system of systems, you build a system anyway, and you can learn much more. And that's how it is going to stay busy. And well, another thing, we started to develop CubeSats for other nations. And that's also a good experience. Maybe I can summarize as space is multinational and multidisciplinary. So that's what we should keep going on.
Fantastic. Thank you for sharing those insights with us, Professor Aslan. So next, I'd like to ask Herman if you'd like to share some of your projects with us.
Yes, good morning, everyone. I've had the privilege in the past to be part of QB50, EU mission originally planned to launch 52-unit CubeSats into low Earth orbit and study the upper ionosphere with a specific set of sensors. And we gained a lot of experience. We contributed actually 2 satellites to the QB50 constellation after we developed the one satellite called ZSat-1. There was also another one that we developed with a private company in South Africa because we didn't have the funding to fund the second one. Currently, I'm retired from university, so I established a company with some of my ex-masters and PhD students called CubeSpace. So we're doing ADCS for small satellites up to microsatellite size or mini satellite size. And some of our recent customers have constellations of satellites. So we supply them with the suitable control systems for a constellation of satellites or to do formation flying, for example. And everyone has different requirements in that regard, and we try to assist them and help them to satisfy their needs. Yes, so I would say we're moving forward in space now with more and more small satellites in constellation format, and it will be an excellent idea for UNISEC to also become part of that and do a constellation where we can not only make it attractive for spacefaring nations to participate, but also for upcoming space nations. There's many countries that's now part of UNISEC-Global that I'm sure that will want to contribute to a constellation like the UNISEC constellation. And we just need to define the correct type of size satellite as well as the application to make it worthwhile and interesting for everyone to participate in that and to get the necessary funding for their satellites.
Thank you very much. And as far as upcoming space nations are concerned, I think Professor Cho will have many things to tell us. So Professor Cho, would you mind sharing what you're currently working on?
Yes. Regarding constellations, I do many things. Regarding constellations, I can talk about 3 things. One is about capacity buildings. Yes, we've been doing BIRDS programs since 2015. And in 2017, we launched 5 1U CubeSat altogether. And I think it is still one of the biggest constellations in Japan. Ironically, the 1U CubeSat, yes. And yes, that's all made by the students from different countries. So it was a quite good capacity building programs. All the stakeholders from each countries. So we've been doing this up to BIRDS 5. And so in total, we launched 17 satellites. So I know how difficult it is to involve all kinds of stakeholders from a different background and from different cultures. So it's quite challenging, but it's doable. And another thing I'm doing is the standardizations and testing. And at my place, we do we have the testing center. So we offer the testing service. And also we work on constellations testings. And right now we are working on testing standard of constellations, how to build and test the mass-produce satellite efficiently. And another aspect of the standardization is a CubeSat interface. That's again to build a satellite quickly. We are working on an interface. So standardization is also, especially the interface, will be very important for the this kind of international constellation. I think QB50 had all kinds of those issues. Yes. Thank you.
Thank you very much. And so Herman was talking about the importance of choosing a correct mission objective. And I think, Professor Gamagawai, as a scientist, you may have lots of insights into mission objectives. So would you mind sharing what your thoughts were?
Okay. Good morning, everyone. So before talking about this topic, so let me introduce my case. This is a good example for the UNISEC. Initially, I'm not familiar with satellite itself, so I'm just really a scientist. So as Max introduced me, I studied earthquake, well, in particular earthquake precursors, and so tsunami. So I presented the tsunami satellite in the mission idea contest 2 days ago. And so natural, the blizzard and lightning and the volcanic eruption. So I studied many things. But so I think just after the Tohoku earthquake, first mission idea contest was held in Japan. So many people noticed that the heavy motion in Tokyo. Then after that, Ray Kawashima-san thought that we need this kind of the earthquake precursor satellite because several 10 years ago, the Russian scientists, mainly Russian scientists, noticed that there is an atmospheric precursor before the earthquake. If we notice that this kind of the atmospheric precursor from the satellite, maybe we hope we can predict earthquake. Maybe it is very useful for the human being. Then after that, so she contacted me. Then so please join the mission idea contest too. But I am not familiar with the satellite design. But so she collected the persons who were in charge of the satellite design. Then I joined. This is the first case. Then I started in the developing this kind of satellite in UNISEC almost more than 10 years ago. Then, but so she also introduced one professor, Professor Yamazaki, you know that. So she also designed the Heptasat for the satellite training. So he also designed many satellites. Then, so we joined. Then we make one team. So designed the earthquake precursor small satellite. This will be good for the satellite constellation, but this is the first case. Then we started this one. Then now our situation is engineering model of our satellite. I think in the future, maybe 2 years later, 1 year later, so we launch this satellite. So, and also we hope this kind of satellite design will be distributed with any UNISEC countries, in particular for the earthquake related country, Chile and Indonesia and something like that. So in this case, if we distribute this kind of the earthquake precursor satellite many times, so we can monitor density for the earthquake precursor. I think this is one of the good case for the satellite constellation in the scientific point of view. So we are now under this situation. I think so. Such as earthquake precursor and also the tsunamis as well. This is good for the science, good science mission for the constellation, in particular in the UNISEC. Thank you.
Fantastic, thank you. So I think that was a great overview of many fascinating projects, and we feel quite optimistic about the future of the constellation. So moving on, I'd like to talk about what are the opportunities for the constellation. And before turning to the panelists, I'd like to ask you in the audience to share your opinion. So I've shown here a survey on the slide. So if you can either scan the QR code or go to slido.com and enter the number you can see on the screen, you'll be able to share your thoughts on what are the opportunities that come to mind when you think of UNISEC Constellation Mission. And then hopefully we will incorporate some of those ideas into the discussion. So if possible, please make your way to the website and provide your input. And we'll then hand over to the panelists to hear what are their reactions. So I'll give you about 2 minutes to complete this. And in the meantime, if you have any...
Yeah, in the meantime, can I just make a comment? I hear what Professor Kamagawa is saying, but I think for UNISEC Constellation, where you want everyone to participate, you have to define something that is truly an international issue, like global warming or the carbon footprint. Tsunamis and earthquakes are definitely important, but only for some countries. So if you want a country like, let's say, Zambia to participate, tsunamis is not an issue for them. They don't have a coast. Earthquakes, I'm not sure. Maybe they have earthquakes. But for South Africa, for example, we don't have a tsunami or an earthquake problem. So we can define a custom payload on the satellites as well to the main payload. And the custom payload can be something like earthquake monitoring or tsunami monitoring. And if you want your sensor, earthquake sensor, also to fly on the satellites of the other clients or other contributors to the constellation, you can supply the sensor to them if they've got volume and space available on their satellite. But the main payload, I think we should think carefully about so that it makes everyone interested to participate.
Yeah, that makes sense. So the system of systems that Rustam was talking about is not only the satellites, but also the different mission objectives we can bring together, the different companies that can provide payloads.
Actually, now we are working on a topic called hybrid space architectures. That's exactly what it is. Different space systems with different sizes, different capabilities, different orbits. So, and also different launch and ground segments, of course.
Right.
Well, but complementing the same goal, towards the same goal.
Yeah, that makes sense. So thank you for providing your comments in the audience as well. And I'd like to pick up a few of these. So when we think of opportunities, things that come to mind are international cooperation. So that's a very important handbook. So I think this means maybe some standards or some knowledge sharing. So that's clearly very important as well. We can see here the idea of sharing in general, standardization, learning, unity and diversity, student experience, formation flight series, underdeveloped countries. So I think these kind of intersect with many of the ideas that the panelists also brought up. But this idea of international cooperation clearly is one of the main points, and that's something that we will explore in the discussion as well. So thank you very much for providing your input and for joining the discussion. So moving towards the opportunities, I'd like to pick up on this idea of international collaboration a bit more and turn back to Professor Cho again to kind of develop this idea. So in terms of opportunities provided by international collaboration, Professor Cho, in your opinion, what are the biggest opportunities?
Well, one country alone, the things you can do is limited. So by involving other countries, if you have two satellites, one satellite alone cannot do much, but if you have two or three, you can achieve more than twice, more than 3 times. And that is quite appealing to the stakeholders because international collaborations, certainly each participant must, commit themselves in terms of funding, to be exact. So they have to pay. And so each country must go to some sponsors. And they have to convince the sponsors, yes, we want to participate in this constellation initiative. So they ask, why do we have to work with others? And then the answer is, by working with others, yes, we can get more. So the obvious things is that even if one satellite fails, still there are other satellites. So the chance of failure, the risk of failures can be minimized. That is number one. Number two, by having more data, I think the result could be much more. So if you have 10 observations by one satellite, but if you have 100 observations at the same time in a different part of the world, I think it certainly improves the value of the mission. For that one, it just saying international collaboration is good, and it's diplomatic, and it will make diplomatic relations good. I think it's a very weak argument. And we should point that practical merit of working together. I think that's all.
That makes sense. So you mentioned the idea of amplifying the impact from a technical perspective, and I think this is something that QB50 was very good at doing. So if you would like Herman to talk a bit more about this, and you gave me some slides, so if you'd like to use the slides to explain your...
Yeah, I can use the slide, but yeah. I just want to say QB50 that worked quite well is we had a yearly symposium, a nanosatellite symposium, where QB50 featured in one or two of the sessions, so that all the participants in the constellation could give specific feedback on aspects of their satellite and their payload, etc. And there was also workshops organized for everyone to learn. I think it's important that if we have a UNISEC constellation, that we will have a couple of days of workshop where everyone can come to, especially the non-spacefaring nations that wants to learn more about how to build a satellite, how to make it reliable, how to test it, where they can learn. And then also present their solutions to whatever problem they are facing in a sort of in a conference environment. That is important. So how can I get the slides?
Yeah, if you press on the big button.
The big button.
Yep.
Yeah, this is just QB50. It was a science mission, and I can't read there. Let me just stand here. There was about 27 countries that participated, and most of them were universities, and also first-time universities that built a CubeSat the first time. And that was also one of the drawbacks of QB50. Most of at that stage, when it started about 2010, when that QB50, there was not a lot of experience in CubeSat. So we started really from nothing, some of the universities. We contributed 2 satellites, so maybe you can quickly go. I'm not going to get into the mission objectives of QB50, but we built these 2 CubeSats. They both flew the same 5X sensor that was supplied to us for free, developed in Germany, to do this mission and do the right measurements that was required. But we also had a custom payload on our 2 satellites that was not the same. On our satellites, we flew a star tracker as well as a gravity wave sensor that was specific to our satellite. And there was people that contributed in the country that developed this gravity wave sensor, and they wanted to see how it performs in orbit. They know how it performs on Earth, terrestrially. And then on the other satellite that was sponsored by a company, Insight 1, that satellite flew the Gecko CubeSat imager. And that imager later became a commercialized imager. Many CubeSats used that imager. It was also used to image the impact of one of the ESA missions on an asteroid, to monitor that impact event with a Gecko imager that was developed during QB50. In our case, we supplied ADCS units to 6 other teams for QB50. That was also developed by us and distributed for free via the University of Surrey to the other teams. and it flew successfully on those satellites, and that led to the establishment of CubeSpace, the company now supplying ADC systems for small satellites. So there was many benefits from QB50 for us specifically, and I'm sure also for the other teams that participated. Sorry.
And thank you very much. And so we learned from your discussion that not only is education promoted through constellations of satellites, but also from an industry viewpoint, it's a great platform to test technologies, develop infrastructure for mass production, and then launch quite a successful company afterwards. So that was really interesting. And in terms of the what Professor Cho mentioned earlier, this idea of having distributed satellites and therefore increase the data and amplify the impact of the mission, I think I'd like to turn again to Professor Kamogawa and ask, so from your perspective, given that a constellation consists of many different sensors and we can conduct distributed measurements, so from your perspective, what types of opportunities do you think that this could provide us with as a scientist?
Yes, I think so. Currently, so we can many measurement on the ground. It is easy way. So, for example, we put the instrument in the Antarctica and we put it in the small island. So we can observe, for example, lightning globally. But in the point of view, the satellites, it's not so easy for many things. So, of course, so if you make a small satellite, we can distribute it. So, but so it's very difficult to uniformly distribute it like this one. Of course, we need many satellites if we need to do that. Then, but so if possible, if we can do this kind of satellite constellation and so many measurements, I think so science will be completely changed. We get completely new data, new insight of the science. So if we try this kind of the constellation of the with some of the instrument and also put in the space uniformly, so we can change science. I believe in this one. And so Professor Herman mentioned that, so it is true. So we have to focus on the global warming of carbon dioxide. This is important because all of the people, all the world, so should pay attention to this kind of things. But I think the earthquake in the tsunami is the limited purpose for the limited use. But so this kind of the measurement is used electromagnetic measurement. So the electromagnetic measurement also contribute to this kind of the global warming, such as things. I think the important things in the payloads. So if we put, for example, electromagnetic payloads, we can research in the global warming, tsunami, and the earthquake, and many things. I think so. In particular, so UNISEC and the satellites should contain this kind of the good payloads, and so we put the many satellites in the space uniformly. So I think so. If we do that, so we can get we can change the science there.
Yeah, absolutely. And I'd like to turn to Rustem, if you have any reactions, or also education, for example.
Yes, I mean, we've also provided two CubeSats to QB50, and we've been one of the 6 to receive the ADCS in addition to Langmuir probes. And I think they've chosen the teams with prior experience. We had our first CubeSat in space and operating for over a year by that time. And as Professor Kamogawa said, I think in situ measurements, they are very important and very critical. For example, we are speaking of space debris. And what is the critical thing for assessment of space debris? It is lifetime. And lifetime depends on the density. And then the purpose of QB50 was to measure the density in space from 420 down to very low altitudes using 50 satellites, distributed randomly, I would say, because of the launch issue. And this may be one of the topics to handle, because knowing the density correctly, well, okay, it helps us predict lifetime, but also other stuff. Like, I mean, anything traveling in space, in low Earth orbit, needs in its calculation the environmental density. And currently those values are measured remotely from remote sensors. And I think maybe this should be one of the topics. And education-wise, and I think it was a very, very big effort, the QB50. The main thing was education, actually, because as Herman pointed out, it was early years of CubeSats, and many nations, it was the era of still spacefaring nations, not like today. Many things changed in the subsequent 12 years. And I think we learned a lot. I mean, another thing, maybe what I can tell, that we had no budget, and actually we did the 2 satellites without budget. So this may be an interesting and appealing way for many other to be contributors to the UNISEC constellation. Well, with our, we had established a space lab in 2007 for the ITU PSAT-1, and since our industry didn't have testing facilities, we had also testing facility before our industry. Now we have lots of stuff in the industry, but, and then having a testing facility helps a lot. And because when you have things which are not proven for space, and with the testing in vacuum and in thermal environment, this is a first step apart from the radiation. And well, with our background, we were able to start the project without budget. We asked government to supply. They first say yes, then they haven't. And in any case, we had, say, friend academic institutions, and they were eager to get into the space business, at least to be known with something in space. And they had some budget for other stuff. They devoted that budget to the project. Well, of course, you should accept to work without salaries or with whatever you have, because you spend, when you don't have a specific budget, you spend everything for the development of the thing. And then you see the students were very eager, and this is education-wise, and again, this is a big thing for their career. Now here, you see, he's a very good example, and we have many more. We have many more. Same, we have many companies came up. Okay, by that time, our government didn't support us, but they had a support program for innovation. So 2 of our students, they established a company, and one developed an onboard computer, other one developed a structure. And they got support from the government, which was used for the project. And when we started keep going, an industry, a big industry, came to us, and they said that, can you do also 1 satellite for us? Then we will buy whatever you need. And then they supplied the other equipment. And well, of course, then the QB50 asked for some contribution, which wasn't much, but which was substantial for us. Was it something like 20, 30,000 euro?
Yeah.
Again, that company also paid that one. And actually, many teams quit the project because of that. But I think this is important because it shows your commitment. So I think, again, in QB50, we should ask for, in UNISEC constellation, there should be some commitment budget from each participant, I would say. And that's another, and meanwhile, we were able to complete, and another important thing, another partner from another university, they had a science project funded by the government. They developed an X-ray detector. So it was flown. Okay, we didn't get data at that time, but now, 10 years later, there is an improved X-ray detector in a current mission, which is functioning well. So I think it was very, very valuable, the QB50 experiment. And in terms of documentation, knowledge, and I think it was indispensable.
Yeah, I just wanted to agree with what Rustam is saying, is that you need to get funding for partially sponsoring the launch, for example. That happened in QB50's case. We only paid the 30,000 euros commitment money, and the rest of the launch was for free. So if the UNISEC constellation can manage to arrange the same thing, it will make it worthwhile for many of the UNISEC chapters in developing countries, for example.
Just one thing to add. I think the contribution of the project QB50 to us was in the order of 400,000 or 500,000 euro.
Wow. So you paid 30,000 and you got
Yes.
10 times.
And we have shown that to all the supporters. Then it's when you say that you have 5,000 receiving, so this helps.
Right.
Yeah, just the last point, what Professor Kamagawa was saying is, I think in situ sensors are also very important. We shouldn't just focus on the space component in the UNISEC constellation, but also give the opportunity to countries to contribute to development of specific sensors, let's say to monitor earthquakes or tsunamis, or the carbon footprint or water all over the globe. So you get much more data through a constellation store and forward means from these sensors. We worked with a company called Astrocast in Switzerland. They developed a system to monitor Internet of Things, IoT, sensors on the ground from their constellation of satellites. You can buy these transceiver modules, very low price, and you can then connect it to a sensor and get the data via your satellite. And if you can distribute these sensors all over the globe, because you have a constellation covering the whole globe, and in that way you can get a lot of data to process afterwards on the ground that will have science benefit.
Right. So in that sense, the opportunity is not only the space segment, but also a ground segment can be developed as part of this mission. And the cost seems like a challenge, but actually it's an opportunity to then build a longer term space ecosystem. So that's quite interesting. So I'd like to now open the floor to some questions from the audience. If you have any questions or comments that you would like to share with the panelists, now's a good chance to ask some questions.
We've got 27 countries, right, in this project. Did you manage it in that time? Because in 2013, does it have a Zoom or some software advisor we can talk over the world? You see that as nowadays, or how did you do it?
Mainly through the workshops, the yearly workshops in Belgium. So you just need to get to Belgium for a week, and there was workshops and there was conference.
We weren't totally dinosaurs.
Well, there was Skype.
Yes, Skype, you can connect, emails. So you got into contact with a lot of different companies and other teams and asked their advice. So it was a collaboration, a collaborative effort.
And in a moment, there were 81 countries, 81. At the end, it was 27.
I have a question about the data availability. How is this handled during QB50? And are there any suggestions now, like, for example, would data acquired by sensors built in some countries be available to other countries for free, for a fee? How is that all structured?
Yeah, all the data was downloaded for your satellite at your ground station. And if you had another ground station with similar equipment, they could also download the data. But then the data was immediately transferred via the internet to a server in Belgium, and everyone had access to that server to get the data from all the satellites. So it was shared. The data was for free. That was the plan. Eventually, not many satellites successfully managed to obtain data from the sensors that was developed. The sensors were quite immature, and not many of them gave measurements that was really useful.
Okay.
Let me just add to that, because we are And I'm from Jishen from Taiwan. We are very lucky because we are part of the QV50 and we also part of the BIRDS project. So we have been involved with the satellite constellation for some time. Back to the question about QV50, I think it's a good project and very good for all the, at least for our university. We are very happy to participate, and we did contribute to the data, to the DPAC maintained by BKI, and I think that's a very good framework. Although originally we don't think BKI did a good job in system engineering, but I think the thing that we push QB50 to be a successful program because they are bounded by a certain time frame, okay, because that's a Europe FP7 project, so they have to deliver to that extent. So back to our UNISEC constellation, I think we had to have a certain deadline because we know when, because whenever we do anything, we ask 5W and 1H. I think who and when should be defined. Who, definitely UNISEC, and when, if we're talking about next 10 years, we may talking about next 20 years because different country or different position may have different plan. Okay, so something that we have to have a consensus for that. And then we can then focus on how and what. I think how is, as Professor Mango Chu had mentioned, currently there are lots of standard, and then we should stick for that, and then that will be conduct the project more effectiveness. But in terms of what, I think we had to reach a consensus. That's my opinion. Thank you.
Yep. Thank you.
Please.
Thank you. Regarding the QB50, what is the main lesson learned from this experience in order to consider it when we implement such experience or such project in UNISEC?
Yeah, I would say the main lesson was that you all working for the same end goal, towards the same end goal. And I agree, we need to have a time frame. QB50 started maybe in 2010 or earlier. We got involved only in 2012. And eventually the constellation was launched in 2018, I think, if I remember correctly. 17. But it was supposed to be launched in 2015, but because not many teams were ready by that time, we didn't have the 50 satellites they were aiming for. It was postponed to 2018, and then still there was only 36 satellites eventually launched into orbit. 31 on the space station, and the others were Indian launch. Mainly the 3 EU satellites were on the Indian launch. But I think the main success of QB50 was not so much the scientific goal of the constellation, because all the sensors were satellite-based sensors, and they were not really mature enough for the mission. But the main success was the educational aspect and the learning aspect for the university that built the first CubeSat by students. So, and if you have a CubeSat built by students first time, there's always teething problems. There's also always issues, but they learn through that one. And afterwards, there's many examples of those universities that build a second and a third satellite quite successfully.
Okay, thank you.
Yeah.
Thank you. Professor Cho?
I have a comment. Yes. Educations, putting educations as the emphasis of the missions works for the first time, but not for the second time. We had those issues in BIRDS programs. Yes, we talk for all the stakeholders are happy for the first one, saying that yes, this is the first satellite of the country. Yes, this is a good capacity buildings, but for the second ones, they expect more. Yes, so simply saying that more educations isn't good enough. It's not appealing. It's really some practicalities of the data or how the data benefits, what is the return of the investment. That's what every stakeholder thinks. So to my opinions, that's really the mission value, especially the science. If the science really needs to be the state-of-art, cutting-edge science must be done. Otherwise, because the CubeSat is already 20 years old, saying that yes, we want to build a CubeSat with other countries and doing constellation good for the educations. Well, I think it only works only in this room, not outside. Yes, so we really need to find a good scientist all over the world. They can have the convince everybody that yes, this scientific value gained from this mission is really worth investing. That's my comment.
Absolutely. So in that sense, I think when we think of first constellation, we have to think about second constellation already, perhaps.
Yes, so QB50 was great. I think QB50 had also very good scientific value. That's why EU funded, I guess. However, but we can say because there are lots of countries who built the first time CubeSat, and for them, simply satellite works, and even if the payload was premature, it's okay. But not for this time.
We're 12 years later than QB50 already, or 13 years, so you should do better than what they've done. But I think we shouldn't exclude contributors to the UNISEC constellation that's maybe not already accustomed to building satellites. We should just help them to build a satellite with a good chance of success. Give them the payload, give them the subsystems that they can build into their satellite.
So there can be two sales package. One applies to everybody. With these missions, we can achieve a world-class scientific result. Yes, this is really world-class science. So this applies to everybody, the developing countries. And second ones, it's up to each country. So for the developed countries, yes, we can even do more or something. And for developing country, they can say, for those countries who build the first time, they can just put educations, or saying that yes, working together with other country, we can learn more quickly. And that really also at the same time, we can have a very good science result. So we prepare two kinds of package. One applies to everybody. One applies to depending on each country, and each country can share the idea. So that's what we did in the BARS programs. All the countries had a different issue of fundraising, and we exchanged all of the information. One country was easy, one country was extremely hard, and one country, yes, they did all the kind of national campaign of the donation or something. So those ideas can be shared also. But yes, each country has a different stakeholder. But we can have one very common benefit, and that must be very, very good ones, and also the independent.
So I'd like to move to the second topic, but beforehand, Rustem, if you'd like to.
Yes, I mean, for the QB50 wasn't an educational project. But since the time was too early to succeed for the project, it became an educational project, setting the pay for today, actually. Now we have the means, we have the expertise, we have the background, we have the facilities, I think, to be very successful for a UNISEC constellation mission, including, as Mengu pointed out, by really educating and supporting the others who will be just starting. So because the main topic was access to space in QB50. So there were main project players receiving funding from the project, and it was all 8 million euro, 4 million for launch, and there were others like us, providers, providing the CubeSat, receiving the implicit funding from the project and providing also funding to build the satellite. So, but then, finally it became an educational. The education part became the most important to set the pay for today. And on the other hand, we learned a lot from European Space Agency's experience through documentation, project management. This was also a great contribution. normally ESA wouldn't provide. And I think that's the thing now. I think currently, I think we can do much, much more because we have we have enough nations to support the others and also to improve ourselves.
Thank you for that. That's a nice way to close the first part of the discussion, the idea that we can do much, much more. So let's strive towards that. But we also need to be aware of the challenges. And this is what I'd like to talk about in the second part of this session. And as in the first part, I'd like to open this part by asking you in the audience to provide some thoughts. So what do you think are the main challenges for the UNISEC Constellation mission? So please take around 2 minutes to provide some thoughts. It could be one word, it could be a sentence. So I'll give you 2 minutes for that. And if any of the panelists have some comments in the meantime, please feel free to share them with us.
I think, again, we should talk of ecosystem. We should consider the complete elements of the project. Then we may, if we start right, and I think we should also consider the TRLs, technology ready, nothing below 6 or even maybe 7. And this would lead to success, I would say.
I think also one shouldn't make the satellites too complex. Limit the satellite size, for example, will be a good idea because you can do much with let's say a 3U CubeSat nowadays. You don't have to go to a 12U or bigger satellite. You make it more affordable as well for teams to participate if the satellite is not too big.
I think besides funding, yes, funding is obvious, but besides funding, I think project management. I think how to manage this international project, I think it's really challenging. Yes.
And Professor Tsudao, so 2 days ago when he was giving his keynote, his closing message was how to combine innovation with simplicity. So Mungu mentioned the importance of creating some world-leading science with this mission, but at the same time, we wanted to think about how to incorporate the least developed countries. So combining this innovation with simplicity somehow seems to be one of the big challenges as well. Yeah.
I mean, we can have CartSats, like we developed just one PCB with capabilities of a spacecraft, and Professor Tiggs has shown something more improved like SlimSat. Yeah. And we have pocket cubes doing well with pocket cubes. So like for the QB50 mission, maybe a pocket cube is enough, and which is at least 1 order of magnitude cheaper than CubeSat.
Yeah.
So again, like I said, hybrid space architecture. So from maybe just a simple chip SAT to a maybe 6, 12U, whatever.
Yeah, right. Yeah, absolutely. Okay, so thank you for providing your input. So let's have a look at what you thought were the main challenges. So we have ADCS, so some opportunities for you, Herman, perhaps there. We also
The challenge.
Yeah. We have funding, management, so maybe this is a response to Professor Cho's comment. Sustainability, so this idea of long-term ecosystem. And we have data sharing. We have how to collaborate effectively between different countries. Different idiosyncrasies, so right, each country, each stakeholder may have different ways of doing things. Standardization, interface, so maybe Professor Cho will have lots to say about that. And politics, so right, this is something that maybe we don't always want to incorporate in space missions, but we have to think about. So all very interesting points. So thank you very much for sharing your thoughts. So moving now to some of the topics I had prepared, but we can obviously talk about other ones. I think one that we've already touched upon is this idea of space ecosystem, especially in the developing space station. So how to develop something more than just one satellite in a country or in a university that is just starting a project. So I think this is a really important point that I'd like to start with, perhaps. So I'm not sure which panelists would like to address this, but how to convert one satellite or one subsystem into something bigger within a university or a country. Any secrets or hints that you want to share with us?
I think I can say a few stuff. The thing is, to commit, to persist, to sustain with whatever you have, and within the UNISEC constellation with so many capabilities, and some will have more, some will have less, But when we get together, I think even the one who has the least will make a contribution, considering the broad spectrum of possibilities in terms of size, mission, different missions. I mean, again, as Herman said, you can, if you like, well, everybody would be part of space segment, I believe, but you can start with the ground segment, like just a ground sensor. And meanwhile, there will be, I think, within the ecosystem, the main established missions, but then anybody can provide anything they like as their own mission.
Right, so that the entry points can take many forms, and then how to continue the momentum, how to keep the project going even after the end of the constellation. Any thoughts about this? It's a very difficult topic. So, Professor Cho?
Yes. Yes. They always have to think the next, yes, before they finish the first one. Yes. And that's really the second satellite is more important than the first satellite. Yes. And obviously, yes, they need to maintain those people who work on the first satellite. If they are gone, I think it's everything's gone. So they have to maintain the peoples. And yes, they need to have a roadmap of the at least 10 years. At least 10 years. And after the first one, what will be the second one, third one, maybe up to number 4, something like that. And so how they go through that ones. And otherwise, yes, it's difficult to maintain that momentum. So it's important that start preparing the second one before the first one finish. Yes.
I'm not sure if I understand correctly, but maybe what I'm thinking is if UNISEC decide they want to have a constellation, make that constellation sustainable. I mean, we launched the first couple of satellites in the first constellation, but then you have to replenish the satellites after 4 or 5 years to maintain the constellation and keep going, keep sensing the data from the sensors on the ground via this constellation. So it becomes a mission that's not only defined for 4 or 5 years. There's no end to the mission, possibly.
Right.
I think, as Mengyu pointed out, the most important thing is people and sustaining the personnel. So, I mean, CubeSat started with non-paid students, but it continued with paid professional engineers. So, and I think this is critical. We will require a balance of those. And another thing, for some nation, the team members may join the other labs to gain hands-on practice. There are many examples, like the BERS projects. We are also doing similar stuff. So I think there are lots of opportunities within that framework. And when we have such a big framework, it also forces the governments and other institutions, well, it will be attractive for them to be part of such a project. Right. But the people, I think, then continue sustaining the people, as Mengyu points out, this is the most critical thing.
One can also give the opportunity to the existing CubeSat suppliers to give their CubeSats or subsystems at a reduced cost to this mission, to make it more affordable for someone to participate. And that doesn't have the experience, for example, in communication systems. They can buy this communication system that has space heritage and that works in orbit at a very much reduced price and participate in this. And that's also where the custom payload comes into it. If you leave room for a custom payload, a participant in his unique environment and conditions can decide, listen, we want to fly this specific system on our satellite as well, just so that everything is not just bought in components, but there's also a locally developed challenge to them. And if it doesn't work, it's only to their detriment. To the constellation, it will not make a difference.
I think Herman just offered us some discounted ADCS, so feel free to.
Sure.
Okay. So I think we're coming almost towards the end of the discussion, so I'd like to open the floor to more questions from the audience. So if you have any questions about what are the biggest challenges that are faced in this type of project.
Hi, sorry. I think this is a recent challenge for every satellite project. So lack of ground stations is one, but getting a frequency is becoming more and more difficult. Since we are like university or research institutions, we always go for the amateur band, which is actually becoming more and more difficult. The radio amateurs are actually expecting more return. If we have such a constellation, how are we going to tackle this issue, especially the frequency and the licensing? So I think this is a challenge that we always tend to forget or try to solve at the last moment. So
I think we simply go to the non-amateur frequencies and apply through the ITUs. And if it is less than 3 years, I think we can use small satellite options. Or I think, yes. Otherwise, I think we cannot use amateur radio first for this one. Yeah. So but if we did the science, there are band allocated to science, and I think we have to use that one. Yeah. No, I don't think there is any magic on this.
One can even involve the radio amateurs in a mission like this, so they can participate in downloading the data and sending the data to the server where the data will be processed. And in that way, they will feel part of maybe something like earthquake monitoring or tsunami monitoring or carbon monitoring, if it's a...
I mean, like our first satellite is in space for 14 years, still sending beacons, and many radio amateurs, they record the signal and we give them certificates and they're very happy. I'm just even for that. And I would suggest now the constellation projects serves very well the purpose of UNISEC. And we may say that we are preparing all nations for space to live in 3 dimensions. And I think we may also get support from UN, making a UN project, like the PhD program.
PNST. Any more questions or comments from audience? Now's the chance. Maybe not.
I'm curious about the management. QB50, there was, I think, European Space Agency involved and von Karman Institute. So how is this could be tackled in case of UNISEC? I mean, who will be the management body for the project?
Ray Kawashima.
Of course, yes. So
I think it's important that we think about that as well. There must be a body overseeing this project, planning it, coordinating it. And if you don't have that, it will just fall apart. So we need to have that. So this is something that must be thought about. I agree. In QB50, it was basically 2 people that was assigned, a retired guy from EU and the VKI. But VKI was not really involved in space a lot. Von Karman Institute is in Rustam's study there. You will know better what they do.
I'm a graduate of VKI, yeah. And it's a fluid dynamics institute, and I'm an aerodynamicist actually.
Yeah, same as me.
Now became astronautical engineer.
Yeah, you went up a few kilometers higher, yeah.
I think, as I said, now the situation is different. I mean, there is, even if you consider the steering committee and with the background experience, but I think, as everybody pointed out, we have to think, or we have to get well prepared for the management. This is really critical.
Yes, thank you.
Then we should spend enough time for that before we really start the project.
Sure.
I would just like to comment maybe a bit more on a technical nature. I feel like standardization of interfaces might be quite important with such an international mission, especially if we would have multiple international partners contributing parts to these satellites. I'm not sure how this was done in QB50, but I'm sure having maybe a technical working group collaborating to establish standard interfaces for CubeSat components might be a good idea.
I think Professor Cho may be the person to ask about this.
Yes, I think definitely interface must be clearly defined and standardized. Yes. Well, right now I'm working on ISO standard of CubeSat interface. Fortunately, it will become ISO within a year or so. ISO 17981 or something. Yes. Well, I think we can add more detail on that one. Yes. So my personal opinions, the easiest way is everybody use the same path and put payload volumes, half U or 1U available, and everybody can do anything on that one. But the interface between the satellite bus and the payload is very clearly defined. And also the mechanical interface to the structure. And that's also the issue of the systems engineers and project management. They first clearly define that one and tell everybody that please follow. If you don't follow, you don't go to space or something like that. So we really need a very good project managers who enforce that interface and also clear document. Yes.
I will add just 2 words: modular and plug and play, based on the interfaces. And if we can succeed that, having modular and plug and play systems, it will be then what you are asking for.
And maybe you will contribute to developing this system. So yeah, that will be nice. Okay, so coming towards the end of the discussion, I'd like to close by asking you to imagine that we are now in the future. So the constellation has been launched. It's operating in space. What do you hope will be the impact of the mission?
I mean, as I mentioned several times, preparing everybody to live in three-dimensional space, to have the background, to give them the background or to acquire the background. And we are going to be space people.
Yeah, if the UNISEC constellation can be so well known that everybody, the man on the street, knows about it, then we made a big success. And if it can contribute to whatever we want to measure, and that will better the life of us all. And when we have a meeting in future year after the UNISEC constellation, and there's thousands of people sitting here and telling their success stories, I think that will be a big success.
Well, if UNISEC constellation works and we can prove that this kind of international collaborations can bring a meaningful result to the real world, I think next time perhaps everybody can go to the moon together.
So as I mentioned before, science will be changed if the UNISEC project is started. And also, I think so UNISEC project will distribute lots of data for any scientist. I think various scientists to use these data, maybe they found new things. I think so. It will be the much diverse for the results. I think this is the final goal of this kind of project.
Fantastic. Thank you so much for sharing your very beautiful visions. So this is now the end of the session, unfortunately. So I would like to extend a big thank you to the speakers. So please thank them on our behalf. Thank you for the great discussion. Okay, and these are some words that have been stated multiple times already by Rei Kawashima, but I'd like to close by repeating them again. So this idea of coming together in space. So if you want to go fast, go alone. And if you want to go far, go together. So let's go together towards the UNISEC constellation mission. Thank you very much. Thank you. Thank you very much.
Very good.
Okay,
Very good.
Okay, thank you. Thank you.
Very good. Very
Thank you.
Very
Thank you.
good. We'll have a short break, so please enjoy some tea or coffee, whatever. Attention, please. Attention, please. It's time. It's time to start next session.
If you can take a seat, please take a seat. Max.
Come on.
Professor Stein, if you can take our seat. No seating, no constellation, so come on.
Professor Kamogawa, please have your seat, please.
Thank you. So we will start our next session, and then the first presenter is Paolo Marzioli, and he will give his presentation on InCave, International Network for Cave Analog Validation Experiments.
Okay, thanks a lot, Chef Ket. Good morning, everyone, again. This is Paolo, UNISEC Italy. So I prepared this talk to propose you an, let's say, an initiative, a project that we might do together with UNISEC-Global all together. That might be fun enough. And it's called, I mean, the acronym is provisional, but we found out that InCave, which means retiring yourselves in caves, might be expanded as International Network for Cave Analog Validation Experiments. I will explain that in a little bit of time. So, scientific introduction, which might sound very boring, but it's to be on the same page. Probably if you imagine and envision the lunar basis, you're seeing in your future something like that, something very futuristic coming out of a sci-fi movie with the nice spheres coming out of the lunar surface, no? So everyone has seen like renderings like that. How it will likely be, or at least how many segments of that will be, are more looking like this. So lava tubes, underground caves in the moon that protect from radiation, from micrometeoroids, and basically structures that can be preserving the astronauts from the outer conditions. Or like that. So these are nice renderings of the lava tubes. The space exploration has been divided historically in two segments, at least for introducing this topic. So all the short-term exploration, especially with the moon programs, was aimed at performing like very temporary exploration activities. So you stay 3 days, 1 week on the moon, and then you come back. And then we began a long-term exploration era where all the astronauts were staying for months in space, and we are now preparing to the Lunar Gateway and for basically outposts that can stay for months or years on another celestial body. With respect to long-term exploration, we have what we call them analog missions. So analog missions are nothing but rehearsals of human activities, predominantly human, in extreme environments that can resemble the actual space extreme, that can be lunar or Martian environment, for many aspects. So these are in general conducted in extreme environments. They can be deserts, they can be the Antarctica, they can be caves, okay? And there are some illustrious examples of bases that can be permanent or they can be temporary for performing these kind of activities. So there are missions where you rehearse to be an astronaut and you can test the procedures, the equipment, the activities, your stress conditions, your psychological conditions, and etc. What we are doing at my university with my group is to develop some, let's say, tiny explorations, but in a very challenging environment. So our project GEA, which stands in Italian for Gruppo Esplorazione Analoghe, which is Analog Exploration Group, is basically aimed at allowing students and researchers from my university in participating in speleology analog activities, so in caves. We have two main objectives. The educational one is that I think it's very important for students now to be educated towards human spaceflight hands-on practices, because there is not much, at least in my university. And the research objective is that you can provide an infrastructure for testing technologies, testing practices, equipment, whatever you want, in a relevant environment, which is very, let's say, difficult to explore. So this is the initial group. You see us during training, and basically the project is realized through a collaboration of my laboratory that you see on the upper side, together with what is basically the speleology authority in Italy, which is the Italian Alpine Club. So they are responsible in front of the nation of giving the official training licenses for going in this kind of extreme environment. The main goal for us is to establish this analog infrastructure. And what we did in the beginning was recruiting 12 among students, researchers, and PhDs, doing training and aiming at a real analog mission, the first trial of 72 hours. I will show that we did 24 hours pre-test right now. This project was started around March 2022. So if you met us just like this, you see the 4 of us from Sapienza here a couple of days ago, you have to know that sometimes we rehearse on another planet. So you can see Alessia, you can see me, you can see Carolina, and unfortunately Michela doesn't go to caves, she doesn't like, but basically it's what we do. So the 3 of us have received the training, and we are, let's say, qualified to go on ropes and to go to the extreme environment and practice. It looks like this. So when you start to explore the environment, it's fairly hard. So this is a chest GoPro during an exploration. This is a particularly narrow passage. So the progression techniques, let's say the training was completed in spring 2022, and they are of course necessary to go in such an environment. So sport-wise, this activity can go up to 1,000 meters of depth into the mountains. Let's say that with analog missions, you don't aim to explore the cave entirely, but you aim to find a suitable, they call it like living room, but enough room for building a base and performing the activities. The organization on our side is done with 12 people that are qualified, and actually now are 18, because in the following year and a half we did other 4 and then another 2. And what happens is that we were aiming to having 2 teams of 6 astronauts that could alternate during the 72 hours mission. These are recent advances. So let's say this is this spring. So we were in one of the rooms that we were selecting in one of the caves that are close to Rome. And we were building a small habitat with a basically insulated tent. We were rehearsing something related to communications. You can see some of us. And basically, what happened in July 2023 is that we completed the first technology test that was aiming at staying with 4 people for 24 hours with a mission control center that was wiring all the data outside the cave. This was a very successful initiative. So you see the 6 speleonauts, we call it like that, so speleology astronauts. You can see the whole team preparing the activities just outside the cave. And the 24-hour test was predominantly aimed at technology testing. So we wanted to see the logistics, basically, and everything that was related to the establishment of connection, power, basically all the stuff that is related to survival. So you can see bathroom, food, heating, and etc. And also two tiny experiments that were mainly aimed at not letting the astronauts be bored for 24 hours. So they needed to perform some activities with procedures related to microplant cultivation and to MFC testing, so energy harvesting through mud or dirt, basically. So we had an habitat inside the cave, which is this, and we had a mission control center that was a huge tent just outside the cave, where we were controlling the activities. Fun fact is that we established all the contacts were wired, but we artificially injected a delay of 2 seconds. So it was very interesting to see basically the students needing to do radio contact with difficulties, because of course you hear the people, they answer to you 2 seconds after you finish speaking. So you need to be extremely clear in communication. So otherwise there is an overlapping, a continuous overlapping. And that was a successful test. Let's say that it's like we received the go-ahead for a future 72-hour mission that we can do this spring. Now, there are some future plans of technologies, and then we will go to the UNISEC initiatives. So we are doing also some LiDAR mapping. This is the result of one of the first activities. So this is how the actual main room looks in 3D. And this is a sort of video game exploring view. So it's like you can play with that and see what we see when we go there. Now, I want to discuss what is later than October and later than December, because that might be very interesting for UNISEC. The in-cave proposal for me is cooperating with everyone to test experiments in cave analog missions. The idea behind that is that we can involve basically everyone. So every UNISEC local chapter can decide, and we can involve potentially high school students to PhDs. Very simple experiments can fit because they are useful for us, because we rehearse procedures from people that we don't know, which is very useful for students that go there, because it's like training to these kind of activities, until complex hardware that might be useful for the science itself. The experiments can be extremely low cost, so it's not comparable to space hardware, let's say space qualified hardware costs, because simple experiments can be also around 25 euros, so something like around like 4,000 yen. The participation can be repeated, so you can, let's say, think of a cyclic participation where you get the things more complex and more complex to have basically an improvement in the student teams or in the participation. Example of experiments can be, for example, a low-cost sensors unit. The needed parts are basically 4, and the cost can be around 50 euros, for example. The development time, I estimate it like 2 days for an MSc student team of 4 students that have no experience. 10 minutes. Okay, yeah, I'm almost at the end. Thank you. We can go over to more complex experiments. This is one of the ones we have, which is basically a continuation of GreenCube. But anyways, like cultivation can take something like 1,000, 1,500 euros. And in that case, you need to leave the experiment in the cave for longer. You need to assess the status of cultivation of plants, and etc. So it's I wanted to provide 2 examples for fit for thought. The proposal is, again, divided in phases, which is the traditional phases of the development of space systems. So we go from development, so local chapter students can develop their experiments to be tested. They have to design properly the system and provide design and procedural files for the operators to operate it. They have maybe to ship it, because if it's extremely easy, we can replicate it. But if it's complex enough, they can ship it to us. We execute it. They have access. So basically, they can access to the mission control center and act like the mission specialist for that part of mission and communicate maybe with the astronauts. Collect the data, and then basically have evaluate all the lessons learned. And maybe the participation is cyclic. Okay? So since we have quite a lot of minutes, I think I did a decent job, let's say. The Q&A that I will ask for this session, so for restarting some activities in UNISEC, is basically related to 3 initial questions, but I'm open to questions anyways. Like, would you participate in an initiative like that, and who do you think it can be okay for participation? Which level would you like to involve? Which topics and experiments can fall under your interest for this idea? And how to realize this initiative, or how to maximize the outcome for UNISEC. And with that, I would, let's say, open a Q&A for the remaining time. And by the way, these are like our social media links, so if likes are appreciated. Any questions, any comments? Yep. Okay.
This.
Thank you. I've got 2 questions regarding these caves on the moon. The first question is, how are these caves located? Do you propose some sort of constellation with some ground penetrating radar, or like are they optically located? And then once located, how is their feasibility determined? Will this be done by sending robots, or will astronauts physically have to explore the cave to determine whether or not they'll be viable?
Okay, clarification. I don't want to send the stuff to the moon, not with this experiment. So lunar lava tubes are located pretty much on the south pole. Let's say you are the experts, so pretty much on the south pole of the moon. They are located, I think, optically by probes, and there is like a mapping initiatives, a mapping probe missions on the moon to locate them, and they are, let's say, a good candidate for exploration. That's how it works. How do they send stuff to lunar lava tubes? Is basically that you will need in the near future, in the far future, a lander, and you have to explore it the way you would explore a cave, but basically with a spacesuit. So also the hardware transportation is problematic. Also the fitting everything on the lander is problematic. But I mean, I'm not proposing anything related to constellation missions or to the real space systems that wants to go to the moon. In this case, it's just analog experiments. So think that I have a way to go there. What would you do there? That is the question. Okay. I hope I answered. Yep.
So I'm curious that in this project, why it have to be this type of cave? Why it doesn't like another type of cave?
Say again?
The type of the cave.
The type
of the cave.
Yeah, I mean, lunar lava tubes is the only type of cave, let's say, that is on the moon, and there are some in several areas of the Earth. In Italy, in particular, there is one. For the analog mission, it depends. It can be a requirement, it can be not. Like for what we do, it's not a strict requirement to go to Earth lava tubes. And we are not considering that because close to Rome, there are not. You need to go to Sicily to that. If it's needed because you need some geology or selenology experiments, in that case, it's feasible. You can organize, you can explore, but it's logistically much more complicated. It depends on the experiment, of course. Okay.
Thank you.
Hi, thank you for your presentation. I have two questions. The first one is, how dangerous is it to do a mission like this, an analog mission here on Earth? And the other one is, how are you going to replicate the low gravity conditions of the moon in those caves that you mentioned?
Okay, I start from the end. Low gravity, it's not possible to replicate, so it's not part of the analogy. So you stay in Earth gravity, unless you want to do some tiny experiments with clinostats that can replicate pretty much the absence of gravity. They are the only long-term simulation way to do it on the Earth. I go back. I was expecting this question, so thank you for that. It's not particularly dangerous. So let's say it's an extreme sport, anyways. You have to be you have to have an insurance for that, and that's basically why we are backed up by CAI, by the Italian Alpine Club. Let's say once someone receives the training, it's not particularly dangerous because you're always with instructors. So you perform the maneuvers yourself, but you don't tie the rope yourself. It's the instructors that are qualified to do it. And these activities to go to the cave are done just by people that receive training. So I'm not considering people going, being an astronaut for this activity, unless they wish to, but there is a training to perform. And let's say time is important in this way because you have all the time of the world to decide what you want to do with the ropes. And also, by now, we are not considering very far rooms in the caves. So let's say the one that you see with the habitats, it's like 60 meters of progression from the surface and 15 meters down. So it's not, let's say, a person that has received a 1 month training can go easily to 300. So it's let's say, you can get tired. It's not particularly dangerous. It's particularly scary when like the heights get to 100 meters, 70 meters, because you see like a deep black hole like below you. But it's not the case for analog missions because it's not needed. That is the sport part.
Okay, thank you.
We can take one more question. Oh, okay.
Professor.
How big is the cave that you normally use near Rome?
Yeah, there is
How big is it?
It's okay, big. It can. That one goes around 350 meters in depth, but we stop at the very first room. So it's the room is like 20 meters by let's say the ceiling is up to 9, but in general it's like 3. So it's like a room for it's like a living room for 6 or 7 people as total space. But of course,
So
it's
the
irregular.
length of the cave, how deep
we
can
have
you go?
we have 150 meters cables.
Okay.
Yeah.
There's cave systems in South Africa that's kilometers.
Yes, I know.
Kangu caves, Sidwala, very big caves.
There are some also in Italy, like in Sardinia, it's like all horizontal and you can go for 20 kilometers easily.
Yes, yeah.
But you can also stop. Like the requirement is that there is the need of no solar light sunlight because you need to lose the circadian rhythm, and not much more than that. You should not hear the voices of people that are mounting stuff outside. So 100 meters are okay as soon as you find the room.
Okay, so size in this case doesn't really matter.
Yeah.
The size of the cave.
Size of the entire cave, no, but size of the room, yes, of course, because you need to perform activities. But the one that we use, it goes over and over, and we just don't use the other part.
Why do you say analog experiments? Why the word analog?
Because there is the analogy with some parts of the lunar lava tube exploration.
Okay.
You need to find it.
So it's not like analog electronics,
No,
digital
no, it's not
electronics.
analog and digital. Everything is digital for our parts, almost.
Cool. Thank you, Paolo, for the great presentation. And
I think
Q&A. We are out of...
Khalil?
Okay.
Quick one.
Yes. Did you, having biological measurement for the participant?
Yeah. Yes, we can have it, but this is a, let's say, big problem because we need to get involved like medicine faculties for that, and we're working on that since a couple of years almost, because they need to sign a protocol for that. At least this is the Italian law. And looking at Max, that says yes, so probably it's an international thing. But it's possible. We have biosensors. So far we are testing them, but we are not retrieving the data. So do it work or not? And do they work or not? But when it will be possible, we will have psychology and medicine also. Okay.
Thank you so much.
Thank you. Thanks a lot.
Oh, you need to switch. Okay. So our next presenter is Honaka Shibita, and she will be presenting the restart of UNISEC-Global.
Thank you. Thank you. So, hello, my name is Honoka Shibata, and I'm a UNISEC student intern. And today I'd like to give a short introduction to UNISEC-Global, which is about to restart as announced by Ms. Rei Kawashima on Wednesday. So before introducing about UNISEC-Global, I'd like to explain a little bit about UNISEC, which is a UNISEC student organization. Under the umbrella of UNISEC Japan, there are two bodies, UNISEC and UNICES, UNISEC Student Organization and UNISEC Alumni Association. So UNISEC is a UNISEC Japan student network across the universities and laboratories. So through this platform of Unison, students can implement joint student-led projects and activities. And based on this successful model, UNISEC-Global was launched in 2013. So this is a global student network consisted of UNISEC-Global student members. So not only Unison Japan members, but also students from other countries. And the aim of this UNISEC-Global was to organize student-led meetings and projects. But due to the COVID pandemic, it has become inactive. But now here, we got to hold this nice UNISEC-Global meeting in person in Tokyo. So why not we restart UNISEC-Global again? So to restart UNISEC-Global, we need to strengthen the connections between UNISEC students across local chapters and regions, so that we have been holding 2 student sessions at this moment. The first one is student session at the 38th virtual UNISEC-Global meeting in October. And the second one is the student session at the 9th UNISEC-Global meeting, which was taking place at this place yesterday. So let me introduce what we did yesterday. So the aim for this student session yesterday was to facilitate information sharing among UNISEC-Global students and to discuss towards UNISEC-Global's inaugural projects. And we did short presentations by each country and region and paper airplane contest, and we had a group discussion on the topics of what students want to achieve during their student life, and also how to make that possible. So here we got some student voices. So these are comments from the students who participated at the student session. So let me introduce some of them. In my group, I found that many students, regardless of wherever they are from, aspire to do research or build their experiences outside of the countries to pursue their dreams and goals. And thus I came up with the idea that UNISEC-Global can become a platform of close interactions among laboratories of various countries. Through discussions with students from different backgrounds and experiences, I was able to learn about the different attitudes and priorities towards satellite development and mission excursion. And sharing each country's situations and position of space engineering industry or academia in society, I could deepen the understanding about the gaps between developing and developed space countries. And this realization enabled me to have a chance to consider the need of international cooperations and more open discussion on this topic. So what do we do now to restart UNISEC-Global? We'd like to start launching UNISEC-Global WhatsApp group because there are currently no efficient ways of communicating between UNISEC-Global students, and rarely exist opportunities for students to present their activities in front of other students from other countries. And currently, UNISEC-Global is just about to start and has almost nothing. UNISEC-Global needs the backbones of its activity and existence value. So we will look into and make use of the strengths and the potential opportunities for UNISEC-Global to grow while dealing with the potential challenges as an international student organization. And at the 39th virtual UNISEC-Global meeting in December, we'd like to make a proposal about the UNISEC-Global to decide how to navigate this future of UNISEC-Global. So here I prepared a WhatsApp QR code for the UNISEC-Global students. So dear students, please join our WhatsApp group from this. And dear professors, please take a photo and share it with your students. Thank you. Oh, really? Yeah. Okay. So thank you for listening. And we have Mr. Sekine to talk about more future student activities.
Honaka, just wait. No, the QR code. Thank you, Honaka. Now I'm inviting Hirotaka Sakini, establishing a university community for deep space exploration.
Thank you for the introduction. Today I have a proposal about establishing a university community for deep space exploration. This might be one of the spin-off activities from the UNISEC-Global. 20 years ago, building CubeSats in university was the frontier. And thanks to the UNISEC-Global UNISEC activities, now so many universities and countries have developed and operated CubeSats and small satellites. So then what we'll do in the next decade? What is the next frontier? I think it might be the deep space exploration, because the importance of deep space exploration is increasing more and more, like Artemis or other countries is going to the moon or beyond the moon to the outer spaces. So then what is the role of the universities? I believe, sorry. So then how about universities? And some universities have developed this deep space CubeSats. Like last year, 10 CubeSats were launched by Space Launch System, and 3 of them were made by universities. And one of them called Equurials, and we developed the Equurials and operated it in my laboratory. And other space student community like MIT's one or Colorado Boulder's one is developing deep space CubeSat as well now. So yeah, I hope more and more universities are involved in deep space exploration future. So to this end, I want to establish the university community for deep space exploration. Here I listed 2 reasons and 2 purposes of this community. One is sharing experiences and information from a student's perspectives. So from experienced students, I would like to listen about the experiences, what was the role in the project, or what were the difficulties in the deep space exploration, and how did you overcome the difficulties. And I love to share my own experience in ADCS operation in Equurials project. And the second one is to learn about the deep space exploration information from professors, include you professors. And yeah, it is important to catch up with the latest information about deep space exploration. What is the current? What is the future? So this is the current plan for this community. The next year, in April, we'd like to establish the community. And then in summer, we'll hold a summer camp in Japan. So I'm now applying for some funding to hold this summer camp. And if you're interested in, please get your own funding in your country to come to Japan again next summer. I hope to meet you again there. And then I want to organize some student groups to propose some mission design, like mission design contest in this summer camp. And after that, we will have paper submission, like mission ID contest. And then finally, we will have the final presentation in the next global UNISEC-Global meeting in front of you professors. And yeah, this might be suitable for the 10th anniversary UNISEC-Global meeting, because we have to think about the next generation or decades in the 10th anniversary. yeah, that's all. So if you're interested in, please contact me. This is just a QR code for my email, but please contact me. And next April, we will start it. And if I can get help from you students, and I can start it before the April, maybe. Yeah, that's all. Thank you.
Any questions to Hirotaka? Nobody wants to do any deep space missions from the students?
Thank you. It's an interesting proposal. What kind of support or interest would you like to see, perhaps from industry?
Supporter, sorry?
What kind of support or interest would you like to see from industry who might be able to help in some way?
So what is the field of the deep space exploration?
Pardon me?
Sorry, your question is about the field of the deep space exploration or industry of the deep space exploration?
With the group that you're trying to set up now?
Mhm.
So you have the interest for students to network and share ideas,
Student community,
and
yeah.
also with academia.
Yeah.
Can you see industry helping you with the establishment of the group and participation in the group?
Yeah, I hope to. So because now more and more companies are involved in deep space exploration, they have money or they have vision for the deep space exploration. It might be a good opportunity for us. And for example, in the next summer camp, I'm planning to invite some private companies like iSpace. So they might inspire us the ideas about deep space exploration. But originally, I want to discuss in the same perspective, like student perspective. So originally, we discuss about it and learn about it and present some mission idea. But to sophisticate to the ideas, then private companies' comment might be useful or convenient. Thank you. Oh, please participate in.
I will just give the microphone to make him uncomfortable.
Anything we can do, just name it.
Thank you.
We shall have.
Thank you.
Just a reminder, Hirotaka, this is recorded. So if they don't, you can bother him again. That he
Yeah.
said. Okay, thank you for your presentation. Now we came to the end of the session. Next part is the best part that we all like. It's lunchtime in 10 minutes. So I think soon somebody will guide us to lunch, sorry. It's a free lunch, not by me, but by UNISEC. So you'll be, okay. So Hanaka will lead us later on. When and where should we, wait, nope.
Announcement. Okay, thank you very much for attending. I'm so surprised to see so many people today. This is the last day, and yesterday, last night, you had quite an exciting night for students, and I'm very pleased that you can come. Okay, so now we have lunch, and the lunch time is 12 to 1:30. So please come back at 1:30, and we will start the workshop for J-Cube at 2 p.m. So please come back here at 1:30 and just relax, and we have some coffee and some sweets. And the other important information is the gala dinner. And if you go to gala dinner, we will meet here at 6 p.m. here, and we go together. And if you want to go to the pier by yourself, you can go. But the ship will go at 7 p.m. So we cannot wait for you if you're late. So I recommend you to come here at 6 p.m. 6 p.m. Okay, so thank you very much for very nice moderation and very nice the presentation. Thank you, and give them the big hand again. ご飯じゃあ